those of you that are watching the recording and here in class, fourth period, we are doing construction number 6 today. Construction number 6. Let me connect it to our screen. All right, so construction number 6, back to our outline that we look at every day. We're going to create a perpendicular line to a line. Create a perpendicular line to a line so that create perpendicular line to a line. Let me ask a question. What does perpendicular mean? Anybody out there want to give it a shot? Perpendicular, define it. Anybody want to give it a shot? All right, let's ask a tougher question. Anybody want to define the word love? Anybody want to define it? You know, love is one of those things that people have a hard time defining. But when they see it, they recognize it. That was a loving act. I can tell those two people are in love. There might be some attributes that lend itself to saying it. Unselfishness, care and concern, anticipation for another person's well-being, other things, loyalty and faithfulness, and all those wonderful terms. But love is one of those things, again, hard to define, but you probably recognize it when you see it. Would you guys agree with me? Okay, perpendicular is a little bit like that, in that it's hard to define. We're going to do our best here, give you a working understanding of what perpendicular means. Basically, perpendicular means two lines intersecting to create a 90-degree angle. Two lines intersecting to create a 90-degree angle. Okay, well now then we've got to define or discuss what in the world is a 90-degree angle. You don't need to do this, but I'm going to make a circle. You can watch. It's going to help us with our understanding. You're welcome to do it if you want. But there's a circle. Can somebody call or recall and tell me what's the degree measure? How many degrees are in a circle? 360. Well done. So 360 degrees. If somebody goes a complete world traveler around the globe, they went 360 degrees. 360 is the degree way that we measure an angle using degrees. So if I were to then use the center of the circle and create like a bullseye, that means I'm dividing the circle into 4 pieces of pie. Now that I'm hungry. The technical term of this is called a sector. The sector, that's 1/4 of it. So if we divided by 4, what do we get? 90 degrees. That also means it's perpendicular. We use that little symbol there. It looks like a little square or a little box. If one of them is 90 degrees, then all 4 of them are 90 degrees. Does that make sense? Okay, sometimes people like to use a protractor. So let's say that I have a line with a dot on it. I line up the dot underneath my circle there, right above it. I line up the line on the line. And I put a mark at 90 degrees. That's how I use a protractor. Now, we don't use the protractor very often for measuring of an angle, but we could. What if I do the same thing here? Line up the point, line up the line, and I go to the 60 degree. All right, so that's 60 degrees. If that's 60 degrees, then this is 30 degrees. If that's 30 degrees and this is 90, then that's 120. I can do all kinds of fun math with that. 30 and 90 is 120. 120 minus 90 is 30. But we don't use the protractor to do this stuff. We use a compass and a straight edge. So let's get into the mechanical part of the lesson. Now that we understand what degree and perpendicular is, let's start off with a line. And now we're going to construct a perpendicular line to a line. All right, to do this, I want to give myself a random point. Doesn't matter where it is, just a random point. From that random point, I'm going to use my compass and go on both sides. An arc on this side. Don't let the compass move on you. And an arc on that side. Because my eyes are so bad, I like to highlight those points of intersections. And now, I'm going to go from those 2 points and get a point of intersection above out here in space. Use the same width on my compass and go from the other point. Use that point of intersection and then the point that I put on the line. And that is 90 degrees. How's that look? Let's try it again. It's this time, what an angle. All right, let's pick out a point. Random point, doesn't matter where. Orange and black, like the Warsaw Tigers. From that point, I get a point of intersection to the left or above it and to the right. I could just make a full circle if I wanted to, but I don't need to. As long as it intersects it on both sides with the same width, We're good. I like to highlight those because my eyes are bad. Now, I go from those 2 points, and I can actually get 3 points. Watch this. I can go above and below both sides. Everyone see the 3 points? One on each side, and then the point that was on the original line. We line up those 3 points and connect. Perpendicular. All right, let me pause there, let you catch up to me. Do I need all 3 points? Nope. 2 points is enough to make a line. Called collinear. I mean they all line up. Tanner, how we doing? You got it? Yeah. All right, we got to do a couple more things with it. All right, let's do a segment now. So not a line, but a segment. That means it has endpoints. All right, so now, as long as I go more than halfway, we did this last week. As long as I go more than halfway, make a big arc. And I'm going above and below. Makes a nice little design. I connect the 2 points. Do they look perpendicular? They do, don't they? Now this one that I drew in, could this be a line or a segment or a ray? Yeah, it could be any of those. All right, we good? Let's try it again now with the segment. Well, let's go the segment as a vertical line. I think I can fit it in over here. A vertical line. I'm going to go on both sides of it. I don't have a lot of room, it doesn't look like over here. Get 2 points of intersection. It's like the fish symbol. Connect those 2 points and voila. All right, we good? You guys see how I do it both ways with a line and a segment? I got one other type of one to do before we do the application. All right, another one that we might do, or you might see, is give yourself a, does not matter if it's a line or a segment, actually. I'm going to make it a line. And then a point not on the line out here. I'm going to call that X. So now what I'm going to do is construct from X to line L. I'm going to construct from X to line L. We'll call this line L. So we're going to construct from point X perpendicular to line L. All right, here's how it works. You're going to start with your compass on X right here. And then your compass has to be wide enough that it intersects the line in two spots. So watch first. And then you can do it. So I want to intersect line L in two spots. I make a smiley face. Aww. Intersects the line in two spots. Then I go from the two spots, the 2 points of intersection, and I get another one. I like just going all the way down here, but I actually can go on either side. From each spot, I get a point of intersection down here. Let me make sure my compass didn't move on me as I did that second one. Yep. All right, you see how I get another point of intersection down there? And now I connect the point X that I started with. That's the whole purpose of it, is to go from a point not on the line. I connect point X to that point. And when I do, it intersects the line perpendicularly. Looks like a smile. He's happy. Glad to be in geometry. All right, let's do another one. All right, we're going to do a line this time. Let's go at an angle. And then a point not on the line. Let's call it M. So we're going from M to, we'll call this line T. M to line T. All right, we go from point M. We're going to intersect line T in two spots. Make sure it's wide enough to get it in two spots. Let me highlight those 2 points. Go from those 2 points and get another point of intersection out here, below or to the left. Don't let your compass move on you. Connect that point of intersection with M. And when I do, that's 90 degrees. Is it? Oh, yeah. Oh, yeah. All right, we all good there? Can you do that? All right, let's start talking some application. All right, so first of all, applications in the real world, man, oh man, is there a lot. All city grids would like to be drawn up perpendicular lines. Elm Street, 10th Street, I don't know what the names of them are, but they could be anything. But they look like grids a lot of times. Even where we're sitting at right now, SHS. What's this road that goes out in front of it? 36. What's this road that goes over here? Raider Road. Guess what? Perpendicular. If you look at from above and you're looking down, you're flying in a hot air balloon or you're looking at a drone or whatever, you'll see that it's done. They try and build them so they're 90 degrees. Now, of course, there are always exceptions. They got hills or creeks or trees or rocks and things that they got to go around sometimes. But surveyors and builders, they're always trying to do things. Well, even look at our classroom. If you look at the floor, you got a bunch of squares down there. If you look in the ceiling, you got a bunch of squares. You look on the walls, you got bricks that are 90 degrees. The wall and the floor forms 90 degrees. Why? Because that's the best, most sound, stable, sturdy construction is when it's done in 90 degrees. Not like the Leaning Tower of Pisa, which wasn't constructed like that, but it has tilted since its construction. So there's all kinds of applications for 90 degrees. All right, draw an acute triangle freehand. Don't use your straight edge. Draw an acute triangle freehand. Don't use your straight edge. Now, if I was going to draw in perpendicular from this point to this segment, it would go about right there. Just eyeball it. Go ahead and draw it in. Turn your paper. Draw in from this point to this side. Just eyeball it. Now, let's go from this side, this point to this side. Eyeball it. Do you think all three of those segments should come together in one point? Yes. They should. What you just drew in and with your freehand are a word for geometry called altitude. That's not the height of a plane. It's the altitude. It's the actual term. It's one that we're going to talk about in our outline. We just drew in three altitudes. What is an altitude? It goes from the vertex perpendicular to the opposite side. That's an altitude. We just drew it in freehand 3 times. But we're going to do it together now with a real construction. Go ahead and give yourself, with your straight edge, an acute triangle. I'm going to focus in. A little bit bigger is better, but this will work for us. That almost looks like an equilateral triangle, doesn't it? But who knows if it is. All right, so to do this, I'm going to envision like each of these are those points that weren't on the line, and I'm going to go to the other segment. So from here to there, from here to there, and from here to there. You can watch this first move and then follow suit. I need to make sure my compass is wide enough that it intersects it in 2 spots. 1, 2. Ooh, right on the point. Nice. AJ, does that make sense? I'm intersecting it in 2 spots. I'm going to highlight those 2 spots. Right there. Right there. Where it highlights those 2 spots. Now I go from those 2 spots and I get another point of intersection. It doesn't matter what my compass width is, as long as I get a point of intersection down here. I can narrow it, I can widen it, does not matter. Then I use that point of intersection to connect it with the vertex. And that is my altitude. It's a segment or a line that goes from the vertex perpendicular to the opposite side. Allie, you got it? Lily? Wyatt? All right. So let's do it again then. Now we're going to go from this point. From this point to this line. First step is to widen my compass so that it intersects the opposite segment in 2 spots. Now, just a word of warning. You may need to extend the side in order to get that second point of intersection. I haven't needed to yet, but you may. Highlight those 2 points of intersection. I'm going to go from these 2 points now, get a point of intersection out here. Natalie, we good? Piece of cake, right? There's the altitude. 2 down, 1 to go. Alex, you good? Abby? All right, here we go. Last one. All right, I'm going to extend the side on this one just because I want to show you how to do it. Meaning, I'm going to pick a width that's a little bit bigger. All right, so width, intersect it here, but it doesn't over here. All right, so does everyone see how it... No, you don't see it because I don't have it on the screen. Everyone see how it doesn't intersect the line over here? And so what I have to do is I'm going to go back to that pink line and I'm going to extend it. Now anytime that I extend, I like to use dotted lines, because then I know that I've extended it. Does that make sense what I just did? Okay, and that's perfectly okay. I now have 2 points of intersection, one there and one there. I'm going to go from those 2 points and get a point of intersection down below. Aha, it's coming together. Should it intersect with the other two? Oh my gosh, look at that. That is really close. How close is it, Caden? Oh, just a little off, isn't it? AJ, look at that. Oh, so close. How does yours look? You guys all come together in 1 point? AJ? Yeah. Conyers? Nice. Rickard? Kinda. Alright, so let's do this again. This time's going to be a challenge. I mean, that one was too easy. That was a piece of cake. This time will be a challenge. Give yourself, do it like I'm doing it, give yourself an obtuse triangle. There's my obtuse angle. Now let me connect. Oh, moved. Almost makes me want to start over, but not quite. Okay, so we have an obtuse triangle. All right, Case. Let's do the easy one first. We're going to go from this vertex to the opposite side. Step one is to get 2 points of intersection from this point, vertex, to the opposite side. 1, 2. Make sure my compass didn't move on me. Looks like it kind of did there. Didn't it? Almost. All right. 1, 2. All right, I'm going to use red. Black and red. What's black and red all over? A newspaper. Okay, so now from those 2 points, I have to get another point of intersection. Don't forget this step. Out here somewhere in space. I can leave my compass the same width or I can change it. Doesn't matter. Now I'm going to connect that point with the vertex. All right, Tanner, 1 down, 2 to go. How you doing? Your compass hanging in there? Tanner, don't lie to me. We good? All right. Okay, good. All right, so now let's go to this one over here. You cannot do it without extending the side. It's impossible. So I'm going to go to this side here, and I'm going to extend the side, come back to it. Am I on it? Oh, I am. And now, like I like to do dotted lines when I extend the side. So I've extended the side with a dotted line. Now I change orientation. Natalie, when I change orientation, why do you think I do it? Any ideas? I just think it's a little easier to look at when this is horizontal. So that means this altitude that I'm going to draw in is vertical. All right, so step one, just like before, I go from the vertex. Now I need 2 points of intersection, but here's where students struggle. They think it's got to be on the inside of the triangle, and it does not. 2 points of intersection, and it's all on the extended parts. 1, 2. I go from those 2 points of intersection to get a third point of intersection down here. As long as I'm over halfway, I'm good. I just went from these 2 points and got that point down here. All right, let's connect. Oh, it's not going to fit. Oh, bummer. Oh, well. Nope, not quite. Oh, well. All right, so 90 degrees. We're good there. 2 down, 1 to go. Abby, you good? All right, so let's go to this third one. What do I got to do first? Extend the side. All right, extended the side. All right, I'm going to go from this point now to this line down there. Got to be fairly precise because I'm running out of paper. One, two. One, two. I go from those 2 points, smiley face. You get a point of intersection down below. Actually, it could be above. It could be either anywhere. As long as my compass doesn't move. Unfortunately, it's not going to finalize like I wanted to, but that's all right. I think you can get the idea. Okay. If I had enough paper, do you think these 3 altitudes would intersect in one spot? Oh, look at that. They sure are coming together. Do yours intersect in one spot? Tanner? Do yours intersect in one spot? Let me quit the video and I'll come around and